4 times 2 is 8. 3. Yeah, 8 over 3.
Okay, and this is again where you got to look at it and be like, okay, is there a way to reduce this?
For 2, no. For 3, no.
So 3 goes into 3, but
Yeah.
it does not go into 8.
Yeah.
So we are done at this point.
Okay.
You ready to try one on your own?
Yes.
Let's go 5 times 3/4. Okay, so go ahead and work that out. Let me know if you have any questions.
Okay. Okay, I got my final answer.
What is your final answer?
15 over 4.
Very good. Okay, now some other problems you might see. Let's say it's 2/3 times 6. Okay.
Okay.
Doesn't matter whether the whole number is on the left or on the right, you still turn it into a fraction. So this time it becomes 2 times 6 over 3 times 1. What does that become?
2 times 6. Wait, let me just write this down really quick.
Okay.
12 over 3.
12 over 3. What does that reduce to?
We can reduce that to 3.
12 divided by 3. So 3 goes into both the top and the bottom.
Yeah.
So
Which,
what does the numerator become?
4 over 1.
Which is 4.
Wait, so I have a question about this one.
Yes.
How did we get the 4 without the fraction?
No, I'm not sure. You mean why is 4 divided by 1 4?
No, like the 4. Wait. So like 4 over 1 wasn't that our final answer, or we always supposed to put a 4?
You never leave it as division by 1. That's the 4 alone is the final answer.
If okay, but if the bottom is 1, it's only 4.
Yes.
Okay.
So here's what you're asking me: is 2 divided by 1 2? Is 3 divided by 1 3?
Yeah.
It is, yeah.
What if it's 2 over 2? Does that still?
So that's a good question. So 2 divided by 2 is 1, because they're the same number on the top and the bottom.
So if I can reduce it, I do that. But what if I can't reduce? I just leave it like that, like 2 over 2. 2.
Well, if it's the same number on the top and the bottom, you can reduce it to 1.
Okay.
So you're asking me different questions, like 4 divided by 4 is also 1. Because they're the same number in the top and the bottom.
Yeah.
Okay, let's try another one here. Let's go 3/5 times 10. Go ahead and try this one on your own, please.
Okay.
You do have to reduce.
Okay, I got my final answer.
Okay, what is your final answer?
6.
It is 6. Very good. Okay, let's try some other ones here. So actually, what's interesting is they don't get much harder than this, but they're doing a lot of ones like this. Let me just look at a couple more questions to see. They're doing a little bit with like modeling. They're not emphasizing that as much. That's okay. Three equal pieces. Sorry, I'm just going through your questions. I don't want you to think I'm like ignoring you at all, but let's do another one here. So let's first do this calculation. So let's so the problem here, there's some graphs to go along with it. What I want you to do, Zoe, is do this multiplication first. I want you to be able to take 3/4 and multiply it by 6, which we know is 6/1. This one does reduce. Okay, so just keep that in mind as you're working through it.
I do this one on my own, right?
Yes, please.
Okay, so I'm gonna multiply first, right?
Yes.
Okay, just wanted to know. Okay, I got my final answer.
Okay, what is your final answer?
9/2.
9/2. Very good. Now, what is the decimal equivalent of 9/2? Do you remember how we did that?
No.
Okay. So to do that, you take the number that's on top and you put the number on the bottom on the inside. Do you remember us doing that at all?
Yeah.
Okay. Sorry, I'm having a bad, this is not correct. I apologize. Two goes on the outside. That is so bad. 9 goes on the inside. Sorry, I got that completely backwards. How many times does 2 go into 9?
2 going to 9. Two.
So 4 times. 2 times 4 is 8. 8 is less than 9. Do you see that?
Yes.
And 9 minus 8 is 1. Okay, so then you can put a decimal place here, 9.0, bring that down, that's 10. How many times does 2 go into 10?
2 going to 10.
Or
Is
what is 10 divided by 2?
10 divided by 2 is 20.
It's
Sorry. Divided. Sorry.
Yeah.
2. Is it 5?
It is 5. Okay, so that's 4.5. Do you see that?
Yeah.
Okay, now let's go back and I'll snip in the answers and there's 2 here that will match up with what you just mentioned here. Maybe this is more of what you saw in class. Which of these end? There's A, B, C, and D. Which of these end at 4.5?
4.5.
Or maybe you can say which ones certainly do not end at 4.5.
Is it D? Wait, 8B?
So B ends at 4.5. What about D? Does it also end at 4.5? Like, are these the same?
Yeah.
They're the same. Okay. Now I can't really speak to why they're doing this, but the one with 6 is what they're looking for. See how there's 6 of these,
Yeah.
and they're each 3/4 in width.
Okay.
Any questions on that?
Wait, can you tell me the question that you asked me?
Well, it's which is the number line, and the answer is
Oh,
D. But I don't really like this question because I'm not sure where it's coming from. But let's
okay.
keep going here. Okay, let's do another multiplication here.
Okay.
All right, so don't worry about which problem can be solved performing this multiplication. Let's actually just have you perform the multiplication.
Okay. I'm doing this one on my own, right?
Yes, please.
Okay. 1, 2, 3. Eight. Okay, got my final answer.
Okay, what is your final answer?
It is 27/8.
Very good. Okay, what is this math operation right there?
Math operation, that's multiplication.
Multiplication. Very good. Okay, now I'm going to snip in some sentences here, and we're going to look for the word that tells us the math operation. Okay, and I'll do this, I think, from easiest to hardest here. Okay, can you go ahead and read this one? Actually, I'll read it here. Kiki has 9 cups of sugar in a bowl. She adds 3/8 cup of sugar to the bowl. How much sugar does Kiki have all together? So there's a key word here that tells you the math operation. Can you identify that word in this sentence? You're welcome to read it one more time.
Is it adding?
Yes. So this one cannot be correct because we're looking for something with multiplication in it.
Yeah.
Okay. Here is another one. These are wrong, by the way. I want you to tell me how you know that this is not multiplication. This is not multiplication, but I want to know why.
Additionally, is that how you say it?
Additional, yeah, that means
Add.
adding.
You were trying to find multiplication.
That's right. All right, so here's one. This one is also wrong, but I want you to tell me why, and I want you to tell me which math operation it actually is.
Is it still have or is it section off or piece of wood that is like cut section off? I think it's he cuts.
If you cut, what math operation is that?
Is that subtraction or
It
addition?
is, it's subtraction, yes. Okay, let's get to the correct answer here. The correct answer is the regular price of a shirt is $9. It's on sale for 3/8 of the original regular price. This word of generally means multiplication. And that's why this one is correct. So the word of is kind of what you're looking for multiplication.
Okay.
All right, so let's look at the next problem here together. We should be able to get this one in. Yeah, absolutely. Okay, go ahead and read this one out loud for us, please.
Nick spends 3 hours writing a report. Evan spent 5/8 as long as Nick on the same assignment. How long did Evan spend writing his report?
Very good. Now the word as long as means multiplication. So which two numbers will you be multiplying?
3 and 5/8.
Okay, so I'd like you to multiply those together, please, and then reduce if at all possible.
Okay. 3, 1, 2, 15, 8. Okay, I got my final answer.
Okay, what do you got?
15/8.
Okay, and that is correct. Let me snip in the answers though, and we're going to see that there's a problem. Do you see your answer here?
No.
No. Are there any that you can eliminate? Like any that you know that are not correct?
The 2 hours
Okay, I would agree. Anything else?
and the 1 and 1/2.
How can you, I'm not saying you're wrong. This actually is one you can eliminate, but how do you know that that's wrong? Like, what is it about that then?
Because the bottom is it 8?
Okay, so that's not that we gotta be careful with that one there. So let's look at this 15/8. And we talked about how you could write this as something over 8 plus something over 8. Okay. Basically, how can you break apart the top number? So 15 is really 8. 15 is really 8 plus what number? What number do you add to 8 to get to 15?
7.
7. And we talked about this a little bit earlier. What is 8 divided by 8?
1.
So there you go. Is that answer there?
Yes.
Yes, it is. Okay, let's do a couple more exercises where we break apart the fraction. So
Okay.
again, whatever fraction I give you, you put that whatever number's on the bottom in these two places. So here's a new problem for you. Let's say it's 17/11. Okay, you put 11 here and 11 here. On the top, you put 11 again, and then you ask yourself what 17 is 11 plus what?
6.
6. So this becomes 1 and 6/11. Do you see that?
Yeah.
Okay, let's have you try another one here.
How
Let's
did you
say,
get the 1 actually?
well, you've told me this a couple times here. If the same numbers on the top and the bottom, right?
Oh, yeah. Sorry.
They divide. No, I'm reminding you that you already know the answer, that you already know how to do this. That's the point, is you already know how to do it. Okay, so here's one for you to try. 8 divided by 5.
Okay, I think I have my final answer.
Okay, did you put 5 and then a 3 on the top?
Yes.
So that's 1 and 3/5. Does that match what you have?
Yes, I do.
Very good. Let's have you try one more. At least one more here. Let's go 16 over 9. Go ahead and try that one, please.
16 over 9. Okay, I got my final answer.
Tell me what you've come up with.
1 and 7 over 9.
Perfect. Excellent. Okay, we're going to go ahead and stop there for our part of the lesson, Zoe. If you want to let Michael tell him to jump on, and I'll see you on Thursday.
Okay, thank you.
You're welcome.
I actually have one question.
Hey, Michael, how are you today? Hey, Michael, can you hear me? Hey, Michael,
Yeah.
how are you today?
Okay.
Just okay. Okay, that means it's like one of those days. You're just like, man, I wish I could start over. How was your weekend?
Good too.
Good. Did you have math class today?
No.
No, so no math class on Tuesday. Got it. All right, well, I just need to get logged back in. Whenever I go to your sister's class, I can't go back to access yours. It's a weird glitch, I would say. But do you remember what you guys were working on? I know we've been doing a lot of angle stuff lately.
I think, yeah, we were doing angles on Monday.
Okay, so I'm seeing big ideas, extended problems. Does that sound right to you?
Yeah.
Okay, let me go to that. All right, I'm almost there. Big ideas, day 2, lesson 4.9. It says you've reached the end of the lesson. Okay. Maybe I'm missing something here. Is there like a Word document that you have to complete here, like a project or anything?
I think so.
Okay, let me change to student and see if that makes this easier. So I can see what you're seeing. Now it says it's complete. Let's go back. All right, well, it looks like we can move on to parallel and perpendicular lines now. So we can do that here. Sorry for all the delay here. It just can't get to where I need to get to where we can actually do some problems. So let me see if I can do that. Okay, there we go. That's what we want. Okay, let's look at something here together here. So I'll snip this problem in and we'll look at it together. All right, so are you seeing my my screen here?
Yeah.
Okay. Eric must draw a line through point P. That's point P that is perpendicular to this vertical line. So do you see how this line is going straight up and down? Do you see that?
Yeah.
Okay, that's a vertical line. Do you remember the name of the line that goes the other direction?
Yeah.
So the line that goes the other direction is a horizontal line. Okay, so watch this. I can draw a horizontal line here. See if I can grab that. Do you see that that line there is sort of horizontal to the other one? Call it a horizontal line.
Yeah.
So horizontal lines go left and right, and vertical lines go up and down. Now, what other point does that horizontal line go through? I don't know if I can get it exact or not. I guess I can't. But what other point does it look like it goes through?
Through 60.
Point is a letter. Is it A, B, or C?
B.
B. Looks like it goes through B. Okay, so let's do you remember what kind of angle this might be at all? I don't know if we've talked about that at all. We talked about 3 different types of angles: acute, obtuse, and then a right angle.
Acute.
So acute would be less than 90. It would be something that looks like that. And obtuse is greater than 90, and a right looks kind of like an L. Does this look like an L over here where the two come together? Does this look like an L, Michael?
Yeah.
Yeah, so if it's an L, that's the right angle. Is that okay?
Yeah.
Okay. Let's do another problem here. Yeah, snip this one in. Okay, Natalie must draw a line through point P that is parallel to this vertical line. Okay, so here's an example of that other line. And just believe that that goes through point P. I know it's kind of off there. If you were to extend both of these lines forever, do you think that they will ever intersect?
No.
No, they will not. So this is the key takeaway. Parallel lines never intersect. They never intersect. Okay. And we see this when you're driving. Like if you're in a car and you're driving down the road and there's a car next to you, if the road is straight and you're driving straight, you guys will never intersect. Is that okay?
Yeah.
So there's kind of two ideas here. One is perpendicular, one is parallel. Parallel lines never intersect. Okay. All right, so here, let me draw two lines for you. Here's a line, and here is a line. Will these lines intersect?
No.
So you have to extend the line. Like you can't just be like, oh, they don't intersect. What if I extend the line forever? Will they now intersect?
No.
They don't hit right here where there's a green dot?
Yeah, we do.
They do. So you have to envision them going on forever. All right. So and that's gonna be hard. That means you're maybe drawing them. So let me look at another example here. Let's go blue. Let's go. All right. So here's a line. And let me grab another line. Here's another line. Do you think that these will ever intersect?
No.
So if you draw them out forever, right, that keeps going, they're not getting any closer to one another. You see that these will never intersect. And that means they are parallel.
Okay.
So I'm just going through your questions here just to see what else you have here. Oh boy, this is very, very geometry based. Okay, let me look for some other problems here for us to look at. Nope, that's not going to work. Okay. Trying to do this again. Okay, so let's go back to perpendicular lines. Perpendicular lines, they meet at a 90-degree angle. Okay, so we've talked about this idea of it being L-shaped. Would you agree with that?
Yeah.
So sometimes they use this box here. This also means 90 degrees or a right angle.
Okay.
So the box means a right angle. Okay. So if I were to give you, if I were to draw a triangle here, and I put a box here, what is the measure of this angle?
A 90-degree angle.
Yeah, it's 90 degrees. Okay, very good. So sometimes it's that simple. You just have to know, okay, the box means that it is 90. Okay, so now let's look at another shape here. Let's say that's 90, that's 90, that's 90, and that's 90. What do 4 90-degree angles add up to?
Uh,
Okay, if that's not clear, let's do something different. Let's say you have an L shaped here. What's the angle measure of that?
190-degree angle.
190-degree angle. And let's say we've got another L shaped here. That's another 90-degree angle. What is 90 degrees plus 90 degrees?
2000.
You're adding them together, adding them together. I want you to add those together, please.
900.
You're adding them together, Michael. 90 plus 90.
Mm, 180.
Very good. Very good. Okay. So now let's go back to my previous problem here. Let's say you have 4 90-degree angles. 1, 2, 3, 4. What do they add up to?
Uh, 360.
360. Very good. Excellent. Okay, so here is a picture with some lines in it. This is line L and this is line M. This is line W. So which lines are perpendicular? So those are the ones that add up to, or they meet at 90-degree angles.
The one that's going straight 3.
So the lines are labeled by letters. So I want you to say like L is perpendicular to M, or
W.
so W is perpendicular to which line? W and what?
M and A.
So W and L are perpendicular.
Okay. W and
How about W and M? Are they perpendicular?
yeah.
Do they meet at a 90-degree angle?
No.
What is this symbol right here?
Oh. A 90-degree angle.
So yes, they are. Okay, now which lines are parallel?
The
Which lines never intersect?
L.
And you have to give me 2 lines. L and which other one?
L and W.
They're parallel. I thought L and W intersected right here. Which 2 lines never intersect?
L and M.
L and M. Very good. All right. Well, we're going to stop here for today, Michael. You did a great job. I really appreciate you